Hi everyone, this is Chris DeLeon of HobbyGameDev.com, and today I'll be giving a quick crash course in how to use Unity to quickly and easily make small, simple games, 3D games on your own. I'm assuming you have no background in using the tool. We're going to try to take you from there to having built a simple car driving game. I want to point out that even though the focus of today's tutorial is a car driving game, a lot of the same camera techniques, code hookup methods, and general navigation of the Unity tool will really map to any game in any genre, whether you're doing an action game, a platformer, a flight simulator, whatever it might be, even a puzzle game. So to begin with, let's show you the end result. That's probably a good place to start. And for that, I'm going to go to hobbygamedev.com/unity/simplecar. And you can see here we have a little car that drives around the environment, bumps off the hills. If it goes off the edge, respawns in the middle. And it's got a few extra features on here, so if I flip the car, I can press a button to reorient it. And also there's different cameras supported, so I have an example of a third-person camera. I have an example of a fixed camera location that follows the car, as well as a first-person view just over the headlights, and an isometric camera in case that's the style of game that you're interested in making. When you collide with a tree, it respawns the car back in the middle of the world. Okay, so let's see how this was put together. We've gone to unity3d.com, it's Unity's official website, and downloaded the tool. It is free to use, and you know, if you want to pay more, there are additional features you could get, but the free version really is covering all that we'll need for the types of games that we're making. So with it downloaded, you will open Unity, and we'll need to create a new project. So let's go to File, New Project, and we're going to replace the words New Project here with Simple Car HGD. I just put HGD there for Hobby Game Dev. You can name, of course, the project anything that you would like. We don't need any of these import packages, but if we want to do special things, we could include those. So go to Create Project. So we have a new empty scene, and we need to get our game started. I want to encourage you, if you're not already, to be using a 2-button mouse. If you have a 2-button mouse, plug it in. It is very, very useful on a Mac. Don't try to do it with a 1-button trackpad. Using Unity in general with a trackpad is just not going to go as well. You're not going to have a good time. So the first thing we need to do is let's build a car out of primitives. And today we're going to go to Game Object, Create Other, Cube. Let's cover a few basic camera navigation notes. If you hold down the middle mouse button, the mouse wheel, and drag, you can pan. If you hold down Alt and left click and drag, you can orbit. To zoom in and out, I use the mouse wheel. And perhaps most importantly, if you're ever disoriented in space and you have an object selected, you can press F and while the mouse is over the viewport, and it'll center the view on the object. And so if I'm way over here and I'm kind of lost, under my hierarchy I can see here's the cube that I made. I can double click it and it will zoom. Or if it's already selected, mouse over the viewport, press F key, and it will zoom in on it and focus on it for me. So now to build this cube into a car, scale wise, let's make this twice as long and half as tall. And you see I'm just typing these in here on the scale values on the side under transform. And so that'll be kind of the body of the car. I duplicated it by clicking on it in the hierarchy, and then I use Command D. It's Control D for you Windows users, or you can go to Edit Duplicate. So now I have a second one. I'm going to drag that up. I'm going to make this into the top of the car. Let's make this not as long. One. Create Other. I'm going to use a cylinder for the tires on the car. Now to rotate, we could use this gizmo to rotate it by hand, and there's even a way to rotate with snap. But instead, because I want it exactly 90 degrees, I'm just going to type in 90. Apparently I want to rotate around the z-axis. I'm just trying them out and seeing, okay, that got me the direction I want for wheels. Let's make it a bit smaller. See where this puts us. 1, 0.3, maybe a little bit bigger, 0.5s. Make it not as wide. There we go. And I'm going to position these little tires in the front of the car. I'm going to duplicate it. Duplicate. And if you click and drag on these arrow handles, you can move it along just that axis, which is a good way to make things that line up. So there. So I have a simple car made. It's my car shape. And we now need to make all these under a single object. This will make it easier to manipulate the car as a whole piece. And so the way that we go about creating kind of a folder concept in Unity is to create a empty game object. Game object, create empty, here in the menu. And this will be our parent for the car, so let's rename this to car all. And then we click and drag each of these pieces we just made into car all. And so now, in addition to manipulating each of these parts, we can select and move around car all if we'd like to move it all as one piece. Let's make the ground. Going to make a new cube for that. Game object, create other, cube. Let's move it below the car because we want the ground below the car. For scale, it can be anything you want. I'm going to make mine 20 by 1 by 20. Again, you see here I'm just typing in scale values. You can see it's down there. So when we hit play, we have kind of a weird view of the scene, right? We've got this silhouette, and we can't really, you and I know it's the car because we placed it there, but it could use some lighting. And so to solve that problem, we're going to add a light, game object, create other. Directional light is what we're going to use here, just because with a point light, with a spotlight, or an area light, we need a number of them to properly light a scene. Directional light works kind of like sunlight, where we can just have one, and that will light everything. Let's move it away from the car. Its position in space actually doesn't matter, just its orientation. And so you can see I use those arrows to drag it away from the car. Remember, if I mouse over the viewport and press F, it'll focus on it. Mouse wheel zoom in to see what I'm doing. I'm going to use the rotation widget up here to affect how it's angled until I get kind of a good diagonal to show the lines on everything as best I can, and that'll do. And so now when I press play, you can see from the light, okay, we have a little better view of a car shape there, but our camera view still wasn't very good for looking at the car. So what we're going to do now is click on the car, mouse over viewport, press F, zoom back out, and kind of, since we know how to move the viewport easily, position the viewport like you would like your gameplay camera to be. And so I'm going to position kind of here in the corner looking down. Then we're going to click on main camera and go to game object, align with view. And what this does is it takes our viewport and sets up the main camera to match its position and orientation. So now when we press play, we see that our camera here has the same sort of view that we expected based on where we set up our viewport. You will notice, by the way, that whenever I press play, mine turns a hideous green. Yours probably isn't. Yours probably turns a shade of gray. This is actually a pretty important thing to know about. I'm going to show you how to set that up. And the reason why I make mine an ugly green, I encourage some people to make it pink or blue or whatever you need, is that while you're in this mode, you can still modify values in the editor. And the risk is that while you're doing this, this is like for testing, if you wanted to move a character into the room or out of the room or move a wall, whatever, these changes get lost. And it's even more confusing if you press pause, because then you're back in your normal editor and you can still make changes, anything you want to do. But as soon as you press play to go back into editing, you lose all those changes that you made while you were in play mode. And so it's important to be able to tell very easily whether or not you're in play mode so you don't make changes and then lose them. So to do that, we're going to go to Unity Preferences. This will be in a slightly different location in Windows, but you can find it. And then in your preferences, play mode tint is what you want to change. By default, it's just a different shade of gray. I don't think it's a severe enough difference. Choose something ugly and eye-catching so it'll be very obvious to you when you're in play mode. Okay, so we have a directional light, we have our camera positioned, we have our play mode tint changed. Let's see, we've got our car under a parent. And so now let's make our car have some gravity. And to do that, we're going to select Car All. We're going to go to Component, Physics, Rigid Body. And this will add rigid body here under the inspector for car all under our hierarchy. And you see use gravity is checked, and so when we press play, we'll see the car drop a little bit and snap down. It's pretty quick. Just as a test, let's take our ground cube, which by the way, instead of calling it cube, let's rename this in the inspector. Selected it in hierarchy, and now I'm going to rename cube to ground. Now let's rotate the ground. Give it an angle, just so we can see when we press play that gravity is in fact working for our car. Okay, it was a little better view. I turn it up steeper, press play. Yeah, there we go. Okay, so gravity clearly is working for our automobile. I'm going to set its rotation here back to 0 to flatten out the ground. Let's give the car some headlights. Since we placed a directional light for the scene, we want to give the car spotlights. So first let's zoom in on our car, click on the car's body and press F. Going to go to Game Object, Create Other Spotlight. So point light is like a round light that emits in all directions. A spotlight is directional, which is what we want for the car's headlight. And you can see initially it starts pointing down, and I'm using the rotate gizmo, this one right here. W, E, and R switch between these, by the way, which is very handy to know. W to move, E to rotate, R to scale. And again, I'm rotating on the circle to get better control over the exact angle. And I can see here that roughly what I want is this thing close to 0, and these other numbers work out so the headlight points ahead. And I'm going to move it using the translation gizmo W, this one right here, kind of about to the position of where a headlight should be. I'm going to move the spotlight inside car all so that it will move when the car does. I'm going to duplicate it and move on to the opposite side of the car. And now when I press play, headlights here in front of the car. And maybe make that more apparent if I'll select both headlights, use the rotation gizmo and point them down a little bit more. And now it'll be much more apparent when I press play. Boom, there's the car's headlights. Now currently the ground is the same shade as everything else, which is kind of making it difficult to see the car. Let's create a new material. And so for that we're going to go to Assets, Create, Material. It wants us to name it. We'll name it Grass. And if you ever need to rename something, you rename it the same way you do in your operating system. So on Mac, that means click on it and then wait. Or you can alternatively press Enter and then rename it. If you're on Windows, I believe F2 will do the trick. And all we're going to change for the grass is to set its main color by clicking on this white box. Let's just make it kind of a grassy green. And now we need to assign this material from our project onto the ground. And we can actually drag it directly here onto any object we want to assign it to. We'll assign it here to the ground. And when we click on ground, now we'll see the material appears under here. It is worth pointing out that this material is a shared resource. So if we assigned grass to more than one object and we change it for any of them, it will change the grass color or material properties for all objects. Now the next thing we're going to do is we want to make the car drivable. Let's go to Assets, Create, C# script. I do want to say that JavaScript, Boo script, and C# script can all be used to do entirely the exact same things. I encourage C# script, if nothing else, because in C# it's a little better at keeping you accidentally making capitalization error, which JavaScript would invent as a new variable. Instead of new behavior script, let's name this a car driver. Okay. Now the first thing we're going to do is going to assign car driver script to car all. So we haven't even written the car driver script yet, but we want to assign it so that we don't write the script and then think it's broken because it's not working. So to do that, I'm going to drag it from project here onto hierarchy on top of car all. And under the inspector, you'll see my bar here got longer. We see the car driver script here when car all is selected in the hierarchy. Let's double click on the car driver script to open it in MonoDevelop. And you can see from the default comments and default functions that start gets called, owner of the script comes into creation, and update is called every frame. Let's add this code into the update function. If input.getKey keycode.w, then transform.position plus equals transform.forward times 5.0f times time.delta time. So this looks kind of complicated. You get used to some of this. It's not really as much of a mess as it seems. The if statement is checking that if the key button W is held down this frame, and this will fire every frame that the key is held down, then it will add to the current position the forward vector from the direction our vehicle is facing. So if our vehicle is turned, this will still make it move the direction the headlights are facing in. Times 5 is just sort of the way we're setting the speed for now, just so it's more noticeable. We'll make this number changeable here in a minute. And time delta time is necessary because the update function gets called every frame, and depending on a machine's system specs, the frame rate may be much higher or much lower. And by multiplying by the amount of time that passes between frames like this, we get a consistent speed independent of frame rate. So we're going to save the script, Control S or Command S, depending on your OS. And let's try it. Press play. And now when I press W, I can see my car is going backwards. I seem to have misunderstood the headlights. And I should have known this. As you'll see here, the Z-axis is pointing this direction. If you hold down Shift, you can select more than one thing at a time, or I think Control or Alt or Command or something. Okay, we're going to rotate the headlights back in front. There we go. And now when I press play, sure enough, W drives my car forward. Let's make it so we can turn the car. We'll just write a new if statement. If input.getKey keycode.a, then here we're going to do transform.rotate 0.0f negative 80.0f times time.delta time 0.0f semicolon. Something else I'd like to point out is that transform is implied to be the position, rotation, and scale data of the object that we've assigned the script to. So if we had a reference to some other game object, we could do that reference .transform and get the position, rotation, and scale of that object. If we don't specify a game object, then it's assumed again to be the one that we assign the script to, or in this case, car_all. We're going to copy and paste the turn code over to the D key and remove the negative. And what this is doing is it's calling a rotate function. Remember, so transform keeps track of rotation, and rotate, there's many ways we can call the rotate function. The one I'm using here, we give it the angles to turn along each axis. So we want to rotate 0 along the x-axis, 80 degrees to the left in this case with a negative, in the y-axis, which is the one that goes up and down through us, again times delta time to accommodate for variable frame rate, and 0.0f along the z-axis because we don't want to roll. If we test this now, we'll save the script, press play, and your car should now rotate and drive. There's no reverse yet, we can add that in a moment. And you can, of course, you can drive it off the edge of the world if you so please. Let's go ahead and add reverse. This will be a very simple change. We're going to duplicate the code that we have for moving forward, assign it to the S key, and we'll subtract instead of add that movement amount. And let's actually change this number also to 2 so that we will move backwards slower than we can move forward, as cars tend to do. I will say that there is a more robust way to handle input that allows the user to remap the key codes. So you could also use the arrows or use a joystick or a gamepad. That won't be covered here, but I will show that example of that in the final source code that will be provided at the end. And so again, let's save that, press play, and we can now drive the car around, including reverse, and take them off the edge of the world. You might be wondering, how do I know those things that I'm doing inside the script? How do I know that those exist? Unity actually has a great script reference, unity3d.com/support/documentation/script reference index.html, and you'll see a link to that on the site. But this provides all kinds of helpful information about what you can and can't do in script, and as well as examples that you can switch to C# or JavaScript. We just have these numbers floating around 5 and 2 and -80. What we're going to do is we're going to make the speed modifiable for our car. Here inside of our class for car driver in the car driver script, I'm going to add public float forward speed equals 5.0f. I'm going to make 3 variables. Backward speed equals 2.0f, and turn rate will equal 80. So we have 3 public float variables. These f's after the 0 are to show the computer that this is a float as opposed to a double precision value. And down here we're going to replace these numbers we had with the variables, forward speed and backward speed. I'm auto-completing, by the way, by pressing enter when it suggests what it was that I was typing. Turn rate and turn rate. Okay, and so all we've done is we've made 3 public variables and replaced where they were in the code down here, saved the script, and now if you click on CarAll in the editor and scroll down in the inspector, you'll see that here these numbers are exposed: forward speed, backward speed, and turn rate, and it inferred those names based on how I camel cased these variable names. See, I called it turn rate with a capital R, so it knew that turn rate was the word. And we can change these numbers here. So if we make the car drive forward much faster, we can change that 5 to 20. And vroom, now it's so much faster than it was previously. If we want to make it move much slower, change that number, and it goes down to a crawl. And so of course this is a really powerful way to make it so you can create an object and then change it inside the editor on a per case basis. Or for example, if a programmer on your team wants to set up something without worrying about tuning, and then have a designer on the team worry about how to get the project's pieces all moving and behaving in a fair and sort of usable manner. It's an advanced and sort of future hint that we are manipulating this car's position directly by changing its transform position. Because it has a rigid body, another way that we could move the object is to apply physical forces to it, and that works a bit differently. Instead of update, we would use the function fixed update, and instead of transform position for our code, we would instead do something that looks like rigid body.add force vector transform.forward, and this would apply a forward force to the car of a certain magnitude. This has a certain type of gameplay that it leads to. I find it sluggish, of course, but for games that are physics based, it's important to use forces to move things around for collision reasons. Also note that I did this in fixed update. The difference between fixed update and update is that fixed update is called a known number of times every second, unlike update, which is frame rate dependent. And so it's important to use fixed update for any code that does physical manipulation to the rigid body for a vehicle or an object. We were able to use rigid body there. It's just like transform, is it implies that it's the rigid body assigned to the game object the script is for. Now let's add a sphere to make hills. Going to go to game object, create other sphere. We have a sphere here. Let's make it let's change its size a bit. I'm going to do 0.74 to make a short flat hill. Move it down so it's halfway underground, using the F key and mouse wheel and stuff to get a close-up view of doing this. Okay, and for now let's just leave it white. Try driving over it, and you will initially encounter that it is going to flip your car. It's very, very oddly tall for how big it looks. And see, the reason for that is because by default a sphere uses spherical collision, which is why we see this big sphere around it. That's what the car is hitting, because it's a faster calculation that can do collisions based purely on distance. What we really want here, component physics mesh collider, Again, this is with the sphere, the hill selected. I'm going to go to Component Physics Mesh Collider. Tell it to replace, because it's saying you already have a sphere collider here. And now it will use the mesh data, the polygons of our shape, instead of assuming it's a sphere, for collision. And so now we have a much more modest bump for the car to ride over, and a lot more sort of smooth driving experience over the top of it. While we're here, let's go ahead and assign grass to the hill so it blends in a bit better. Let's create a better system for our camera. One way to do this, sort of a very easy, I might say lazy way to do it, if we just click on the vehicle and move our viewport around to where we'd like it to be for a third-person camera, and then we click on main camera and do the same trick from earlier. Our game object align with view. That'll put the camera where our view is. And remember, it'll stay there, but if we make it a child of car all, then it will move along as the car does. And we now have sort of a third-person camera. But this results in an extremely rigid camera, which isn't very nice. It's not very smooth. We don't have as much control over sort of making it lag behind the car or any effects like that. So let's move the camera back out of car all, and let's instead control the camera with a script. We'll go to Assets, Create, C# script, and we'll call this car cam. Okay, now selecting car cam, going to that script in mono. We are going to create a few new variables. Public camera, use camera, public transform, track object, and then inside the update function we're going to tell use camera dot transform to look at track object. And now the way this is being set up, we can specify any camera to track any object, and it will constantly point itself at that object. We could have the object assume that what we've assigned it to is the camera or is the object to be tracked. Instead, we've written this in such a way you can swap them out, partly just to show how to make those connections inside the editor through various ways. And this will also, by centralizing it in this fashion, make it easier for us to change the ways that camera can be switched between if we want to have multiple camera modes supported. So let's go back to the editor. You'll see now we have our car cam script, but it's not yet assigned to anything. It doesn't really matter what it's assigned to. Let's assign it to our car just for sanity. And now when we scroll down here, you see the car cam wants to know which camera should track which object. And there's two ways to do this. The one that I like is to drag here from the hierarchy main camera onto where it says use camera, and it fills in that slot with the camera information from that object. Now for track object, it wants to transform, and I could drag car all onto it. Instead, I'm going to click on this mark next to it, which gives me a list of everything that has a transform, all the things that I could have dragged onto it, and I can select car all, double click that, and it fills in with the transform of car all. And so now when I drive around, the camera is constantly following the car, which is kind of a nicer camera than either of our previous ones that we tried out. There's other ways we could control the camera to switch between camera modes. I'll include the source for that in the final version, but I'm not going to show you here. Let's add more hills though. So I'm going to duplicate the hill. Again, that's Control D. I also want to say that just like there's this green arrow we can drag up and down with, there's that green square which allows us to drag it perpendicular to that axis, which in the case of our hills is a really handy way to keep them flush with the ground while we change their dimensions. We can have some bigger hills and some smaller hills, some longer hills. Duplicate these two, rotate them. There's really no harm in them overlapping as long as it's kind of the shapes that you want. 1.5, 2, there we go. And now when I drive my car around on them, you can see it bumps around, pushes its way over a bit. Oh, the car toppled over again. And we can still drive, you know, that could be dealt with another way. But we want to give the car a way to reorient itself when it gets flipped, kind of like the Warthog from Halo. Before we do that, let's do a little bit of cleanup. We have these spheres floating around. Let's call those each hill. Actually, I'm going to select all three. Name them all hill at the same time. And we already have a ground object. Let's make them children of the ground object, just for keeping organized. There. Inside of our car driver script, we want to add a new key to reorient the car. Let's make that the X key. We know it's going to look a lot like the previous one, so we can copy and paste for our check line. Except now instead of get key, we're going to use a different function. We're going to use get key down. And the difference here is that whereas get key triggers every frame the key is held, get key down only does it the first frame that the key has been pushed. Because we don't want to do this constantly, we just want it to happen once when the key goes down. And we're going to do several things to the car when the X key is pressed. Transform.position plus equals vector3.up. This will lift the car 1 unit off the ground. We're using vector3.up because it's an objective up vector. If we added instead transform.up, it would be up from relative to the car. So if the car's on its side, this could be, east or west, depending on which way the car is rolled over, or it could even be down if the car's upside down. But by adding vector3.up, it's an objective up vector that'll always be away from the ground. We're going to do rigidbody.velocity equals vector3.0. And this will stop movement of the car, so that if it's in the middle of tumbling, it will stop its lateral movement. And related to if it's tumbling is we're going to set the angular velocity to vector3.0. This will prevent it from rolling. Otherwise, when we reorient it, it could keep having that roll component. And then lastly, we're going to do one that's going to be a little fancier looking. Transform.rotation equals quaternion dot look rotation transform dot forward vector3 dot up. I broke line here just for my low resolution editor that I'm using for the camera capture. You don't have to worry about breaking line there if you want this all one line. Transform forward is telling it the direction to maintain for the way the car should be pointed. Vector3.up is telling it which vector to make upright. And so this is going to make our car sit upright. Otherwise, all we'd be doing would be bumping a meter into the air and zeroing its spin and movement. But this is the part that really does work of setting the vehicle straight. If we try it now, we can press play. And if I flip the car over on its side, this is always hardest when I have to, there we go, oh, I'm upside down, that's great. Now when I press X, pop, you can see the car is upright again. So if I mess up the car and I press X, boink, then it's good again. Now quaternions are kind of a complicated subject. They're important since otherwise there are problems that emerge from using yaw, pitch, and roll, something called gimbal lock if you want to search for it. The thing about quaternions though is even though they're very complicated from a math perspective, as programmers in Unity we don't actually have to understand them so much as we have to know what it is that we can do with them. And so for that you can actually just look at the autocomplete for quaternion and you'll see there's all kinds of interesting things to read the documentation about how to use, but they're very powerful, very handy, and as long as you know what functions to call, it's actually not the end of the world if you aren't the kind of mathematician that knows exactly how to do those things, say on paper, or to write the code that makes them work. Now if the car falls off the edge of the world, that's still a problem, because we can upright the car if it flips, but if the car drives off the edge of the world, it's just gone. There's no saving it. I mean, you could keep tapping the upright button, and you can still drive in the air. But let's pretend like that doesn't work, because, you know, that shouldn't, and we should fix that on a day when we have more time. So instead, let's make it so that if the car goes below a certain point, it will respawn at a given location. So let's create two new public variables, each of them a transform because we want a position. Lowest ground object, this is the indication of when the car has gone too low. And the other public transform will be respawn position. This will be where we'll set the car when we've caught that it goes too low. Let's do this inside update. We care each frame whether this has happened. If the car's transform position vertically, or Y, is less than the lowest ground object's position .y, then we want to set transform, which is our car's position, to respawn's position. If you think about this, it makes sense. It's again kind of wonky if you haven't gotten used to it yet, but we're comparing the y position of our car to the y position of the ground object we're going to feed it. And if we were below it, we're going to set the car's position to match the position of our respawn point. That does mean that now in the editor, when we click on car all, our script does want two more references. It wants the lowest ground object to be assigned, and it wants respawn position. Lowest ground object is just simply the ground. We'll drag ground onto it. Again, filling in that position that way. You could also have clicked on this thing if you want everything with a transform. Now respawn position we don't have yet. So let's create one. All we need for that is position in space. So go to game object, create empty, which gives us a coordinate with rotation but no other data associated with it. And let's just set it over here just for an example, because we'll know that it's a very particular spot here to the right of the camera, and it's not necessarily where the car started, but it's as close, it's a safe position. We'll call that respawn spot. Can name it whatever we like. This is just to stay organized. And now for car all, we will assign respawn spot to respawn position. And if we test our script, there we go. Car can drive off the edge of the world, and we can pick it back up with the X key. And so you can see there that the car is keeping the tumble from when it goes off the edge of the world. Another way that we can fix that, I guess the simplest way, is if we also set transform.rotation to the respawn position's rotation. And now it doesn't matter that the car was upside down when it fell, it will be the orientation of the respawn position. You'll see we're still spinning. So for that we could borrow code if we wanted from this X button to stop the car spinning and so on. Not terribly important to worry about, but if we want to see what that looks like, it's a more stable respawn system. And now what if we want the car to respawn exactly where the car started? I think that's a sensible expectation for the player. We want to put the respawn spot exactly on top of the car, and there's a very easy way to do this in Unity. So the position coordinates of a transform are relative to a parent. So if we make respawn spot temporarily a child of car all, and then we zero out its transform data, it will center it on the car. And we can also zero out its rotation to make sure it's the same orientation. It looks like we already are. And now we'll make respawn spot no longer a child of the car, so it won't move when the car does, and it recorrects the transform data to be world coordinates. So now, when we respawn, we'll respawn in exactly the same position as our car started in. And that's just a handy little trick in Unity to center one object's coordinates and orientation on another one. Let's create a tree trunk. Let's have a tree to crash into. And for that we're going to go game object, create other, let's make it out of a cylinder. It makes sense to me. You can see by default the cylinder isn't very tall. Let's make it taller, maybe not that tall. Drag it up and down. Yeah, that's kind of a good height, maybe a little bit skinnier. It's probably taller than it needs to be. And this is sort of as practice. Let's give it a new material. Assets, create material. What color instead of white? Tree trunk looking brown. I accidentally forgot to name it, so it says new material. Again, I'm going to use Enter on a Mac, F2 on Windows to rename that to tree trunk color. I'm going to drag that onto the tree trunk. And then we need a top of the tree. For that I'm going to, let's rename this cylinder to trunk. Game object, create other sphere. Tree top. And let's make that grass colored because it's close enough to a tree. And it's kind of a little extreme. There we go. We got a nice little tree going right there. Now we could make trunk a child of treetop or treetop a child of trunk to stay organized. What I recommend instead is to create a completely new game object, create empty. Call this full tree. And we're going to make both the treetop and the trunk child of full tree. The reason for this is this allows us to keep the scale of the parent 1, 1, 1. If you make either one of these scaled objects a child of the other, scale can get messy when you start to do rotations of children and so on. So I prefer to create an empty and use that kind of as a folder like we showed earlier. So we have a tree now, and sure enough we can crash into it just like we always did. Bump. But let's make it so when you crash into the tree it respawns the car. And so the first thing we're going to need to do for that is create a new C# script. Create C# script, assets, create C# script. We're going to name that reset from crash. And then inside this script, reset from crash, we're not going to write any code for starter update. Instead, we are going to write code for a function called onCollisionEnter, which has one argument, collision, the collision. And this is code that gets called whenever a rigid body collision occurs. Car driver, other objects script equals the collision dot game object dot get component car driver parentheses semicolon. I realize this looks kind of alien. We'll walk through in a second how this works and what it's doing. And then if other object script does not equal to null, we're going to call other object script dot respawn. And now let's go back to car driver, which is the script we're pointing to. We're going to create a public function called respawn, in which, so here we have code already for how to respawn and update for when you go below the earth. Let's just change that to a call to this function, and we're going to move that code. I copy and pasted it from down there up to respawn. So now if we fall off the edge of the earth, it will respawn the car, meaning it will execute this code for the car. But also if we crash into the tree, because this function is public, we can call it on the other object that collided with us. And this is a really powerful way in Unity, or a powerful thing to be able to do in Unity, to get a script on the other object. So this is checking, does the other object that I have this collision with as the tree, does it have the car driver script attached? And if it does, or call the respawn function on that object. Now we're not quite out clear, unfortunately, because if we try this now, well, so first of all we haven't attached it yet. So let's go to our full tree. Let's attach reset from crash. But again, we're not going to have any results yet, and this can be frustrating for Unity of why doesn't it respawn me yet. And the reason is the tree has to be a rigid body. Like I said, onCollisionEnter is an event thrown when rigid bodies collide, but the tree is not. So let's go to component physics rigid body. And so now we can collide with the tree and the car should respawn, and it does. I will say though that our tree fell over. That's a problem. The way we need to avoid that is to tell it that this tree is kinematic. We're going to check mark it. That's actually the same, I believe, as setting constraints, as turning on all 6 of these boxes to freeze position and rotation. And this just tells it, don't let physics code move this object. We just want to use this to detect collisions and things like that. And so now we collide with a tree, it respawns us in the same way that let's verify that driving off the edge still works too, and it does. Next up, we're going to cover briefly the prefab system, which is a powerful way in Unity to create sort of an exemplar object and the modifications of it. So let's go to Asset, Create Prefab. Over here we're going to name the prefab. I'm going to name it TreeFab because I think that's outstanding. Now we're going to drag full tree, the parent object, onto TreeFab. And now here's the magic. We can drag TreeFab onto the ground all over the place. Let's throw some trees around. And each one of these is already hooked up the same way as our first tree, with a rigid body and with the scripts attached and so on, so that when the car drives around and collides with them, it gets respawned in the middle. And even more interesting, so you can see they each have their own position, so the position data here is in bold. You can make changes to these, so I can make the scale of the tree top on this one, let's make it bigger. And then let's make this tree's trunk taller and thicker. 2, 2, 5, let's make this a huge tree. Treetop. 10, 10, 10. Yeah, so massive tree over here. And they'll all still act the same. You can see there's our huge tree. It respawns us, just like our lower, bigger top tree is. And we can take those changes, which you can see are again are highlighted in bold, and we can either be like, you know what, I didn't mean to make this tree so big. I want it to be exactly the way my default prefab is. If we click on revert, it will take it back to the properties of our common prefab object here under project. Or if we've made changes to one, like let's say I had turrets, and this actually happened in Freezing Solid recently. I had turrets and I made one of them play a little bit better by adjusting its tuning parameters, and I wanted all the turrets like that. So let's say that we decided this tree works better with what we're going for. We'll click on that one tree, and here under prefab options, instead of revert, if we click apply, it'll make all the prefabs catch up to the settings that were bold, except position, and we'll take on those connections and qualities. Our sky is gray, which is kind of unfortunate, or I guess it's kind of a bluish. But we want to have control over the sky, and so let's create a new material, and we'll name that sky color. Change the color from white here to whatever shade of blue you like. There we go. There's a blue for the sky. Let's go to Edit. Render settings is where we can set the skybox. This is also where we could set up fog if we wanted it. And we're going to drag sky color onto skybox material. You can see there it instantly filled in, and now we have a color of our sky. You could use cube maps and other fancy things for this. We're not going to worry about that here. It's just give you some control over making it look a little less like the template. And again, fog, if you want to check it on and things and play with those values, you are more than welcome. Let's also add text. This is a very useful basic skill. Game object, create other GUI text. And it's going to, by default, appear in the middle of the screen. Let's set its position to 0, which is the left side, 1, which is the top, 0. And the reason why those are the edges is because the anchor is set to the upper left. We could change this to make it appear in another corner if we so pleased. Now let's set the text for it. I'm going to say car sample in Unity, what is it? I think Alt-Enter by Chris Delion. An Alt-Enter is the way that I go to a next line. It may be different in Windows, but there's probably some key combination with Enter to get a new line instead of completing the text box. And so now when we play the game, those words appear there, and so it's a good way to credit your work in case it gets lifted and shows up elsewhere on the internet, or to provide instructions or whatever your needs might be. And just like any of the other objects, you can connect this up to code to read out positional data and so on. So if we want to go to the car driver script, let's say we want public GUI text debug output. And we're going to hook up our text object to this. Inside update, let's say that we're really concerned with knowing the car's X position for whatever reason. Then we're just going to set the debug output. Actually, I'm going to make that a string. Empty string plus whatever, we'll make a string out of it trivially. So we're going to set the text property of our GUI text to the X position of the car. And then don't forget under car all that we have to hook up debug output to our GUI text object. So from the hierarchy, there it is to our debug output. That's with car all selected in the inspector. And now as I drive around, we can see that value. And so this, of course, is a handy way to provide arbitrarily complex or even spatially relevant data as you're working on debugging features of your game by showing text on the screen. One last thing that we also need to account for is we need to find code that we know will always be running. In our case, car driver seems pretty safe. But something to be careful of, right, is if the car got removed from the universe, say it exploded, this code will no longer run. We need to put what I'm about to show you in code that will always be running, which for this program we know is here. Let's do input dot get key keycode dot escape. So if the user presses the escape key, then we're going to do application dot quit. This will not show up in a web version. This will not work inside the Unity editor, but this is absolutely essential if you are doing a local Windows or Macintosh build, so that someone can quit your game without having to control it, delete, or force quit it. It's a little insane to me that this isn't built into the program, but developer be warned, add this to your program. It will save you trouble and save your user frustration. So again, escape key will do nothing here, but when we export the program now, we can use escape to quit, which will be very handy. That's it for now, except for making a build. So let's go to File, Build Settings, and this is of course where Unity shines. Here we can tell it we want a Mac OS X build, and click Build, and it'll let us choose where we want to put it. I like to create a folder called Deploy inside my project and save all my outputs there. Car Mac. Get it? It'll take a second to output the project information. And it'll show us the version, and I can now run that. It by default lets me choose my properties. Let's play it windowed. It's going to be my full screen. And there's my game. I can drive around, I can re-rent the car, go off the edge of the earth. Everything still works. My trees, of course, I updated the prefab like we showed. I'm still getting the debug text output. And if I press escape, it'll close that since we added that important code. You can also output the PC, the Windows build, even on Mac. Again, I like to put it in my deploy folder. Car PC, that one's less of a pun on a famous game designer's name. Take it a moment. And then the other thing we can do is we can output for web player. All of these, of course, are free. With Unity, you have to pay for the other output options. Don't worry about those for now. Deploy, car web. And when you output for web, it'll give you an HTML file with the file already embedded. Car Unity, car HTML. And so this is actually all that I had to do to output the sample build that I showed at the start of this walkthrough, was just outputting the build this way and posting that HTML file to the web. And again, everything works. Escape key is ignored harmlessly. And I hope you've had a good time following this tutorial. I know it's not beautiful, but hopefully it's enough to get some people started in exploring Unity and all the great things you can do with it. If you've got questions, please let me know. I'd be happy to answer them. I might do a follow-up video showing sound, some various other kind of hookups, camera techniques, if folks are interested. If you want the full source code, check it out. It's going to be on a blog entry at hobbygamedev.com. Thanks again, and have a good time with it. Bye-bye.